Hi everyone, we are going to continue our videos on proofs. Rocky is sitting right next to me, so I am sure you're going to hear him bark at some point. So we're going to continue to add on to our theorems, okay, and today we're going to learn about the addition and subtraction theorems. And this comes into play with segments and angles. So it says draw a line LE, and then put N between L and E, and then I between L and N. Then it says LI is congruent to NE. What conclusion can you make? And there it is. The conclusion that we can make is the fact that if we take segment LI and add it to segment IN, that's the same thing as IN plus NE. The reason being, if you think about this, if these two are congruent, so let's assign them a number, let's say 4, and IN is 5, well, no matter what, if we add the same segment to a congruent segment, it's going to be congruent, right? Because 4 plus 5 equals 5 plus 4. So that is actually one of our theorems. This is a part of the addition theorem, which states that if the same segment or angles is added to congruent segments or angles, then the sums are congruent. And that's what we just did in this example. Okay, we took two congruent segments, LI and NE, and we added IN to both. So we took the same segment and added it to two congruent segments, so the sum is congruent. So for our final statement, we're going to say LN is congruent to IE. Okay. All right, we're going to draw that same exact diagram again. So we have L and E, N, and I. This time, we're going to mark LN congruent to IE. So LN is congruent to IE. What conclusion can we make? Well, if we take LI and subtract IN from it and do the same thing over here, take IE and subtract IN, you're going to get congruent parts. So let's say this whole length was 9, right? So this is 9, this is 9. And then I said, take away IN from both. What are you left with? 4 and 4. Those are congruent. So LI is congruent to NE. So this time, this is going to be the subtraction theorem, which states that if the same segment or angles is subtracted from congruent segments or angles, then the differences are congruent. And here's another theorem for us to know. And we're going to add on to these. So we have 2 more to go. Okay. Let's go to the next slide. All right, this time we are going to draw GO. We're going to put point E between GO. Then we're going to draw FN and put U between. GO is fun. Don't you love it? All right, so it says OG is congruent to NF. So that means that this is congruent to this. And EG is congruent to UF. Careful, I almost said that backwards. So what does that mean? Well, let's give these as numbers. I think sometimes when you assign numbers to values, it makes more sense. So let's say GO is 10 and FN is 10. Then EG is 3 and UF is 3. What does that say about EO and UN? That they're both going to be 7, so these are congruent. So we can say EO is congruent to UN. This is part of the subtraction theorem, which states that if the segments, I forgot a word. If the congruent segments or angles are subtracted from congruent segments or angles, then the differences are congruent. Okay, and that's exactly what we did. We took, oh no, I don't know why I did this already. Okay, phew, still moving. Sorry, the diagram moved a little bit, but we took these congruent segments, subtracted them from congruent segments, so the differences were congruent. Okay, all right, last one, and then we're going to put this into practice. So again, we're going to draw GO with E in between and FN with U between. So this time it says EG is congruent to NU and EO is congruent to UF. Let's assign these numbers again. So let's say this is 2 and 2, this and 3 and 3. If we add these 2 segments together, the full segment's going to be 5. So GO is congruent to FN, which basically states if you take congruent segments and add congruent segments, then their sums are going to be congruent. So if congruent segments or angles are added to congruent segments or angles, then the sums are congruent. So just to highlight that again, we took congruent segments and added congruent segments, so their sums were congruent. Okay, next slide. It says determine which angles are congruent that are not marked. Justify your answers. Well, we can say that angle NAL is congruent to angle LGN. The reason being is because triangles are made up of three angles, right? We have a triangle here and a triangle here. So if two of the angles of a triangle are congruent, then it follows that the third must also be congruent. Okay? And you can kind of write that out in your own words. All right, so let's go ahead and apply some. So angle ANG is 2x squared minus 4x. Angle ALG is x squared plus 12. Okay? Why can I set those equal together? Because right here, congruent, 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 congruent. If you take congruent angles and you add them to other congruent angles, then the sums are going to be congruent. So we subtract x squared from both sides. We get x squared minus 4x equals 12. Remember that to solve a quadratic, if it has a linear term, you need to get it set equal to 0. When you move across the equal sign, you need to do the inverse operation. So I get x minus 6 times x plus 2 equals 0. So x equals negative 2 and 6. Remember that if the problem asks for x, you must include it, regardless if it's negative or not. Okay, and it's possible that a negative angle can work. Or not a negative angle, a negative variable can work. So measure of angle ANG is going to be 2 times negative 2 squared minus 4 times negative 2, which gives me 16 degrees. And then let's plug that in to ALG as well. If these are supposed to be congruent, remember that they should be the same number when I'm done. If not, I made a mistake somewhere. Okay, good thing is it turned out all right. Then we have to do that again with 6. And we get 48 degrees. Again, take the time, check your math, don't just assume. Make sure you get the right answer. All right, so the next example, we're not going to go through the whole thing, but it says determine which segments are congruent that are not given. So you have GO is congruent to EM. Since they share the same segment in the middle, we can say that GE is congruent to OM. So if we know those two are congruent, we don't even need this middle information of EO. We can just set these two equal to each other and solve. That's the whole if you have, this is the subtraction one, that if you have congruent segments and you take away the same segment, then the differences are congruent. So you have 3x equal 11, so x equals 11 over 3, that's okay. Then it says find EM. So for EM, we do need both this time. We need this and this. So we take 6 times 11 over 3 minus 4 plus 9 times 11 over 3 minus 12. And if you take the time to do the math, you should get 39. All right, let's get into the actual proofs now. So one thing we do need to know is what's known as the reflexive property. The reflexive property just states that an angle is or a segment, a line, a ray is congruent to itself. So if I said, angle A, well, angle A is congruent to angle A. Okay, so let's look at the next slide. And this is our last page of notes. So it says angle TEV is congruent to angle XEW, and that's given. Remember, anything that's given to you, you can go ahead and draw on the diagram. So TEV is congruent to XEW. Prove that TEW is congruent to XEV. Well, notice that they share the same angle, okay? But we have to state that that angle is congruent to itself. So we're going to say angle VEW is congruent to angle VEW by the reflexive property. Because now we have two pairs of congruent angles. Since we have two pairs of congruent angles, I can say the proof that angle TEW is congruent to angle XEV by, if an angle is added to congruent angles, then the sums are congruent. Okay, we couldn't just jump to step 3 right away because we had to state that this was congruent to itself so that we actually had two pairs. Whenever you're using these addition and subtraction properties, you need two pairs. Okay, so we only had one pair at the time. Now, sometimes both pairs are going to be given to you right off from the get-go, but sometimes you have to find the other pair. So, perfect example of that is in proof 2, we're given that GO is congruent to GS. So GO is congruent to GS, and HO is congruent to TS. HO is congruent to TS. Notice that we have two pairs, and so we have two pairs of segments. We can use our theorems. Prove that GH is congruent to GT. And we can do that right from the get-go because we are taking away, we have congruent segments and we're taking away congruent segments. So that means that the differences will also be congruent. So GH is congruent to GT. So if congruent segments are subtracted from congruent segments, then the differences are congruent. Okay, where in the previous proof, we took two angles and added them together and the sums were congruent. Here we subtracted them, the sums were congruent, or the differences, excuse me, were congruent. Okay. Last proof. So we are given that ray SR bisects angle ASE. Anything that's given we can mark. So SR bisects ASE. So that means that these two are congruent. We also know that angle CSA is congruent to angle ESY. So CSA is congruent to ESY. So we have both of our pairs. However, we knew that this bisected, okay, but we have to clarify, we have to declare basically that these two are congruent. So I probably shouldn't have marked those right away. I should have said it's bisected. What does that imply? If it's bisected, then that means that these are congruent. So I have to state that first. So angle ASR is congruent to angle RSE. And the reason being is because if a ray bisects an angle, then it divides the angle into two congruent parts. Now I have two pairs of congruent angles. Okay? And therefore, I can go ahead and sum this up. No pun intended on that one. That CSR is congruent to RSY, because if congruent angles are added to congruent angles, then the sums are congruent. So when you want to use these addition and subtraction theorems for segments and angles, you need to make sure that you have two pairs of congruent segments and angles. And then that's either, are you adding, are you subtracting, or are you comparing it to the same angle? Okay. Or same segment. All right. Please come with questions if you have them. Thanks so much again, you guys. Appreciate all the time you take on this and taking notes. Have a wonderful day.